Good day everyone, my name is Chen from University Technology Malaysia UTM. Today I would like to present our paper with the title Application of Knowledge-Oriented Convolutional Neural Network for Causal Relation Extraction in South China Sea Conflict Issue, which is supervised by Prof. Maya, Dr. ANAZIDA, BINTI, ZAINAL. First, let me highlight the main focus of this paper is to learn the causal relation from online news article that related to the South China Sea SCS conflict. I would like to introduce what is causality. Causality is relation between cause and effect as known as causal relation. It is very important as it can help in explanation, decision making, and also event prediction. So how causality can help us in this importance? It allows us to understand the pattern and learn the correlation of the event happen. Next, I would like to introduce the case study of this research, which is South China Sea conflict. This conflict is due to overlapping of territorial claims in the South China Sea area. There are several countries involved in this conflict, which is Brunei, China, Taiwan, and also our country Malaysia, Indonesia, Philippines, and also Vietnam. In South China Sea, they are rich of resources such as oil and natural gas. It also won 5 trillion US dollar as it is a key commercial where one-third of the world's shipping will pass through here. There are also some issues happen in the South China Sea between the China and Vietnam and also Indonesia with Vietnam, and some cybersecurity issues such as the Trojan and also malware that involved in the South China Sea cyber attack. So why it is important to learn the causality from the SCS dispute? This is because if the issue happen in our country, it will jeopardize our national security, which will bring loss of money and people from our country. Therefore, learning causality can help government to understand the causal relation easily and help them in decision making that related to the national security. So the performance statement of this research is the online news article are in unstructured. We need to search for specific news article in order to obtain the news that we want. Due to the online news will update frequently, hence we need to find the related news and read it one by one, which is valid at times. Besides that, the current approach of the causal relation extraction has some limitation to extract the compress of the causality well from the natural language text. This is because the human language is compressed and vary of representation of a sentence. Machine nowadays still cannot fully understand the human language. So our research aim is to improve the performance of the KCNN that was proposed by the Lee and Mao to extract the causal relation from the SCS online news article. For the preliminaries and related work, I would like to discuss about the causality extraction technique here. In order to extract the causality, there are three approaches, which is rule-based, machine learning, and also deep learning. The rule-based method is that we set the rules and find out the causality. However, the result is low and this method can only extracting experiencing and simple causative verb form on it. For the next approach is the machine learning, which is using the existing tools such as NER, POS to extract the causal relation. But there are large amount of label data need and many error is found. In recently, the deep learning approach is used. Deep learning is applying neural network to extract the causal relation, and the current work shows that this approach have a better result than the machine learning because it has the better semantic and synthetic analysis to capture the complexity of the captured expression. I have compared the current existing approach for the causal relation extraction. As we can see, the state of art is using machine learning and deep learning approach. Recently, there are some researchers show that deep learning and convolutional neural network approach can extract causal relation more accurate. Therefore, in this research, I decided to apply CNN method to extract the causal relation. Here is the basic architecture of a convolutional neural network, which consists of layers such as convolution layer, mass pooling layer, and also fully connected layer. For methodology, there are three phases for the methodology, which is phase 1, data pre-processing, phase 2, causal relation extraction, and lastly is the comparison different architecture of the KCNN model. In phase 1, data pre-processing, we will annotate the cause and effect by using the breadth annotation tool and also lemmatizing using the wordnet lemmatized. And lastly is the sentence representation to transform the word to the vector. In phase 2 is the causal relation extraction. First, we will construct a word filter automatically, which is extract the causal word from the friend net. Next, we will develop a KCN model by using the PY touch. You can see the picture shown is the KCN architecture, which consists of the word embedding, and then we will pass in into convolution network, then to the max pooling, and lastly is the output. Last, we will train and test the KCN model with the data. So in phase 3, we'll compare different architecture of the KCN model. First, we will change the max pooling layer to the average pooling layer. And then next, we will also add a data orientation channel into the KCN method to compare the performance with the base model, which is the KCN model that contains a knowledge-oriented channel on it. Lastly is to exchange the pooling layer from the max pooling layer to the average pooling layer for the both channels. So this is the dataset we collected that are related to the SCS dispute, and all of the dataset is collected from the National News Agency. And here is the sample of the causal phase that we extracted from the news article. For the data distribution, 80% of the total data will become the training data, and the rest will be the testing data, which is 20%. So the performance measurement will be used is the F1 score, precision, and also the recall. For research design and implementation, they are also the same as the methodology. There are 3 phases: for data processing, causal relation extraction, and also the comparison. So in phase 1, the data pre-processing annotation. Here is the annotation for the by using the break annotation, and then the entity extracted. Next, I will extract it into the text form with the relation also. Lastly, we'll labelize the sentence into the lower form and also the base form, and with the index of the entity, the cause and effect. And the relation will extract into another text. Is the sentences representation, which convert the word to the vector. And here is the example of the word embedding table. And it is downloaded from the cs.yot.ac.uk link. Then we will look through this word embedding table to find the words that in our data, and then we will extract it into a new table. Then we will store the words in the data into a table with an index where this index is represent the vector that we found in the word embedding table. Next is the generation of the word filter bank. Here's the friend net, and inside that there's a lexical unit that represent the causative words. So we will find through the friend that related to the causal, then we will extract the lexical unit to build our word filter bank. Then is to develop the KCN model by using the PY touch, and it contains 4 layers: embedding, convolution, pooling, and also output layer. In this way, we'll use the knowledge-oriented channel as the convolution layer. And lastly is using the software classifier to classify the relation. Next, we will train the model with the 152 training data, and with 100 ePower, and the page size is 20. For the testing data is 39, and the label is not provided. Lastly is to compare with the different architecture of the CNN model. There are 6 different architectures we will discuss later about the detail, and they are compared by using the micro average F1 score. For the result analysis and discussion, this table is show the result for the KCN model. We can see that for the class cause and effect, the F1 score is 72, and the effect cause is the 66.67. So overall, the average is 69.33. Next is to compare the 6 different architecture. For a better explanation, I have labeled them with her name. As you can see, for the first and 2 is KCN, KMax, and also KAVG is actually represent the average pooling layer. For the first one is the base KCN model, which we have developed in the phase 2, is with the knowledge-oriented channel only and using the max pooling layer. So second one, KAVG, is changing the max pooling layer to the average pooling layer. So for the third one is KCN, KMax underscore DMax. This architecture contains knowledge-oriented and data-oriented channel, which is actually proposed by the Lee and Mao. So for the fourth, fifth, and sixth, it's very modified from the architecture proposed by Lee and Mao, which we change the pooling layer from the max pooling layer to the average layer, and we interchange the average and the max pooling layer to see which is more suitable for the SES data. So from this table, we can see that the higher score for the cause effect is actually KCN with K average and D max. And for effect cost, it's actually the KCN, K average, and D average. And overall, for the highest average, F1 score is actually KCN with the K average and D average, which show that actually the average pooling layer is the most suitable architecture for this SES data. So the most suitable architecture to extract the causal relation extraction from the SCS online news article is the KCN model with knowledge-oriented channel and data-oriented channel, with both channels using the average pooling layer. In conclusion, this research has studied the application of KCNN to extract the causal relation extraction from the SCS online news article. By referring to the least and mouse work, it can help people or the government to understand easily the causal events that happen in the SCS dispute to increase the awareness of the national security. And lastly, we found that the most suitable architecture model is the KCNN with the knowledge-oriented channel and data-oriented channel, with both channels using the average pooling layer. That's all for my presentation. Thank you.